So as you can see, the crystal is rotating inside, the chamber is lit on, the top is very bright but it's gonna be inside the hilt, so you're gonna just see light coming out of some of the fissures inside the hilt. And the bottom will contain the batteries, and probably they are doing them, I'm thinking maybe the top or maybe the bottom, it doesn't matter. And I will add a potentiometer to the rotating crystal to make it rotate slower, as it makes a lot of noise and it rotates really too fast anyway. But for now this is it. I'll just get the potentiometer and continue working on the hilt next. There's also, by the way, the possibility of changing the color to any color you really want. You see here, I'll just change this value in the equation to 225 to another one, just random number. It's up to 225, any of them, and it will give you a different number, so the possibilities are infinite really. And then you load it up on the Arduino, and you will see now the color is changed to blue. You can do it again. This time I'll put 0 here and 225 here. Load it up again. That's it. Loaded red. So you can continue playing and finding your own color, and this color will also be transmitted to the blade because I welded other connections here to connect directly to the blade, so whenever the crystal changes, the blade changes too. That's it for now. So after a long deliberation, I decided to slow it down with a power controller. So I attached this little thing to the positive wire that goes directly to the motor that moves the crystal. So just the positive, chop in the middle, connect these two. These ones are very cheap. You can get basically each one of them was 30p on Amazon. And this is the result. I also decided to not fickle too much with the squeaky sound, because it actually sounds like a lightsaber sound. If you put it together with the audio file that I will connect to the rest of the saber later, it will have an amazing mix. Furthermore, if you want to, you can actually use this moderator to increase the speed or decrease it. I'll make it accessible through the hilt, so you can actually touch it while you're carrying it around and change the speed of your crystal. But that's it for the crystal chamber. Okay, so we're gonna deal with the electrics now. This is gonna be a lot of welding, which you know is not my favorite part, but it will give the needed result to have an actual lightsaber instead of just having a piece of plastic. Okay, so the best light-saber software that I could find was by a guy that has a website called Kyber, and I think he's Russian, and he explained how the circuit needs to be connected properly, and made an entire program which fits inside an Arduino Nano. It basically fills up its entire memory, is to the limit, but it has so many functionalities that I think this is the best software you can possibly get. So I'll put a link of this down in the description, and now I'll start explaining what I have on the table. Okay, so I'm gonna remove the Arduino Uno because I'm gonna use the Nano instead, much smaller, lighter. I have a button with LED. This is constant press button, so basically when you press it, the status stays on until you press it again, it goes off, and you can choose statuses with it. An on and off button, so just a normal button to put next to a battery. An Arduino speaker. This is new, I've never used it before, and I saw it on the internet, very cheap, and I thought, as it is a very powerful speaker apparently, I might use this one instead of a normal connection speaker. Also, it saves me the time to go and do connections with other parts of Arduino to remove the excess electricity and etc. This has everything already installed inside. A micro SD card reader, because the sounds for the board will come from this. So you need to get a micro SD and use this connection to bring it inside the Arduino. Then I'm gonna make the batteries rechargeable by plugging in a socket. So this is a rechargeable unit for Arduino. You connect it directly to the positive and negative wires of the battery container, and it will just charge them whenever you plug it in. And this last piece is called an MPU, and basically what it does, it controls how the board is situated, if it gets hit, if it moves back and forth, down, up, and it tells the Arduino that this is happening, so that it can make sounds whenever it gets hit, or it can swish whenever you're moving it. So every sound is directly connected to the movement of the light-saber while you're using it. I'm gonna have also LED strips. These are 5 meters, you only need 2 really. And there are 3 connectors inside. Yeah, ignore this one. The red is the power, the V5, the green is the ground, and the white is the signal. So it's perfect for what we need. And these little connectors, these ones are for the blade. Basically, when you're gonna clip the blade in, I don't want the blade to be constantly on. You can remove it and take it off and bring the light-saber around as a switched off light-saber. But when you want to, I want you to be able to plug in the blade like that. It will stay fixed on, connecting all the electrical circuit without having to screw it in and anything else. You just plug in, plug out. So this is a female-male connector, and I have 3 of them because there are 3 connections to the LED. So what we need to start doing now is, first of all, remove the Arduino Uno. We don't need it anymore. Just put it away. And we're going to keep this one because we need 12V for the other components that I added. And I'm going to add to the circuit, which is already well documented, extra bits to have this connected to. And the battery pack is too big to fit inside the hilt. Yes, literally too big. So what I'm going to do is crack it open without disconnecting it and put a battery behind, glued in. But more of that later. We will need a lot of wires because all these connections need to be done somehow, and a lot of welding. So wish me luck. Start with welding the connectors here. do is connect each one of them like that, so it's easier. Just a drop each, and it should hold together. Put it more in the middle so it's visible what I'm doing. Okay. And you can see why I don't love welding. Everything you do is a problem. Okay, so basically I made some horrifying melting of metal. Some would call it butchery, but I managed to connect all the connectors to the board and weld them properly, more or less. Same thing here. So the next phase is connecting wires, and some of them have double connections, so basically the same wire supplies electricity or signal to another one. So what I'm going to try and do is create a two connection wire by simply peeling off some plastic. Okay, so I divided the wire in two, totally on purpose, and these wires are very thin, but at the same time they're also very useful in this size, because you're gonna have to fit a lot of electronics inside a very little space. And the light-saber hilt was originally something else. I think a flashlight for cinema. So it wasn't really made to contain all the electronics that it's supposed to. So very delicate cuts, so you don't remove the copper wire from inside. There it is. And now the other side. Wish me luck. There you go. Okay, this will require again welding, but first try to tie up both sides. To the bend connector. Do you see? We have that and this. I don't know if it's visible. So you're gonna have to connect these two together like that. Okay, twisted it on, and I'm gonna do the same thing with this other one. Okay, so we have two wires connected together, and now I'm gonna weld them together, hopefully. Okay. So they seem to be welded together. I'm gonna cover it also in hot glue so it holds it quite strongly. And this needs to be... Yeah, unfortunately I made a mistake. This was supposed to be... Yeah, but it doesn't matter. I'm just gonna weld it to this. So VCC, it's written here on the MPU. So weld one of them to the VCC. I think it would be easier, but it's not. We'll eventually get a hand on welding. Until then, you'll have to suffer my horrible welding. Almost there. Burn the table. Then once this is done, place the other cable on top and weld that too. You have to weld it properly, otherwise it won't hold it. And this way is better. Okay, so I welded it. The ones of you that actually know how to weld will probably be laughing now. But I managed. Okay, so this one's connected here. This one's connected to the 3v3, which is here. Okay, simple connection. See, when you don't need welding, this is much easier. Then you take this, and this has CS, CK, GN, and what you need connected to is the VCC. Okay, so that's the power connector to both of them. Now, next step, connect CS to that. Let me check. Double female one. Male, female. The problem with having so many cables but all mixed up is that you always have to look for one, and it's never the right one that comes out. So what I suggest is have better organization than me. Okay, so CS. There's a connector called CS here. Connect it here. And then the CS goes to connector 8. Should be around here. It's called D8. Make sure they're well connected. You're gonna put hot glue on top of it anyway to hold them from ever coming off, but only do it after everything's connected and you know that it's working. Okay, so the MOSI, M-O-S-I, goes connected to D11. There's one here called MOSI connected, and that one goes to D11. Remember not to change anything in the programming, otherwise, unless you know what you're doing, otherwise every connector has been programmed to be giving a certain signal. If you change the connectors values in the program, you will not connect anything properly, and you might even short circuit and break the board. So the CLK to D13. Sorry, SCK. Which is the last one here. Okay, and the last two missing are the MISO. MISO. I also have chopped wires that I never throw away here. So the MISO goes in D12. MISO in D12. Which is the last one here. And then the last one is the ground, which goes to 80. Ground, let's see if I can find dark color. Yeah, dark color, ground. And that one goes to 80, which is this one here. Okay, now connecting the other board. Try to keep the wires in order, otherwise it also gets messy. So the other board has a lot of connectors too. Remember, all of this will be covered in hot glue so it doesn't move anymore after you tested it. So here we need an SDA, so you don't need to connect everything.
Here's what I found on reference.com.
Computer, stop. I really need to change the password for that. Yeah, SDA. And then this one goes to A4. There you go. Nope. Nope. This one, SCL A5. We're basically gonna fill in the entire board in Arduino with all the connections. So that's why you need a bit of space inside the hilt. Yeah. And then the last one is the ground in A1. Ground A1. There you go, ground. goes to A1 here. It's good if they're all, the connections are a bit hard, because it means that they won't come out easily. Managed to do something incredible here, which is push out a pin while I was pushing cable, which shouldn't even happen. As a matter of fact, it doesn't go back in. That's interesting. Ah, there it goes. Okay. So as I was saying, good if they're hard. Don't over push them. You push the pin out like I do here. I should really not say anything like that. I have an amazing luck with these things. No. There you go. Oh, it is touching anyway, so doesn't matter. Pretty sure they will come hunting me back, but we'll see later. Okay, so this is where it gets a bit more complicated. I want to wire the button, but because I'm going to put the board up here in the blade, I'm going to have to make a connection to the button which will be placed down here. And remember, I passed those wires through the hilt before and tied them up in an attractive way so that they wouldn't look too odd. Well, I have 3 exits, so I'm going to use all of them just for the button. The other 2 are already used to bring electricity up to the board, but that's all we need. So I'm going to do one thing. I'm going to connect an extension to each one of them. So green to green. Here's yellow. Here, yellow to yellow. And white to white. So as usual, green will be ground, white will be type V5 or V3, and yellow will be the data transfer. The thing is, this doesn't have a connector which connects directly to this input. So what we're going to do is remove the plastic bit from the cables. Easy, just remove it without cracking the rest. There you go. It's gone. Do the same with power positive. Okay, this ones will definitely need to stay together, so I'm going to melt them together instead of using hot glue which will just occupy space. Use the welder to fuse the wires together. This will not come off easily. Do the same for the white. Just make sure that they're properly connected. Okay. And do the same with the green. It's down here. Just melt them together so they don't come off. Don't melt them too much, otherwise it will expose the metal part, which should not touch the rest. Okay. Keep on stripping the wires. Just remove the top part. You don't have to remove the entire plastic. I'm very picky, so I remove all the plastic bits, but there's no need. As long as wire is exposed, the tip of the wire is exposed. There's a metal bit which makes it a little bit easier to weld after, so thankfully that will help me. And don't connect the wrong wires. Remember this green, white, yellow here. Okay, so that's done. So we said green is ground. It's very small here, but there is a positive and a negative there. Just need to see it. Okay, so connect the green to the negative. It will be welding them again. So what I'm gonna do just gonna melt some metal inside. It's a bit too much melting. is enough to connect. Now I'm gonna place this one here. Okay. It's finding a position to